Hi, this is Dr. John Bergduff. In this lesson, we're going to look at rationalizing denominators. Now, this is actually a lesson in etiquette. Now, there are lots of rules of etiquette in real life that have sort of fallen by the wayside. Here's a couple that you may have heard about or read about. For many, many years, it was considered impolite for a gentleman to wear a hat in the presence of a lady. And it was considered more than impolite, scandalous, for a lady to show her ankles. Now, most rules of etiquette have more or less gone by the wayside historically when it comes to dress, and there's still a few in behavior here and there. But in mathematics, there are rules of etiquette that have held on for a long time and are still in effect. And one of those is these. It is considered impolite and bad form to leave a radical in the denominator of a fraction, like you see right here, or to leave a fraction under a radical. We don't want to leave any of our answers in either of those forms. So what we're going to do is we're going to look at a process called rationalizing the denominator. Now, where does that come from? It's easiest to see if we focus on this denominator right here. 5 is not a perfect square, so from previous videos, we know that the principal square root of 5 would be an irrational number. Rationalizing the denominator means doing something or other to make sure there are no irrational numbers in any denominators. So we're attempting to rationalize them, make them into something rational. And the process of doing so varies a little bit depending on whether there is one term or two in the denominator. In this video, we're only going to look at one term in the denominator. In another video, there's a lesson about what if there's two terms in the denominator. And for our purposes today, the only radicals we're going to look at are square roots. Let's jump right in. So suppose we want to rationalize this denominator, or the denominator in this expression, 25 divided by the square root of 5. There's an irrational number in the denominator that's impolite. We cannot leave that there. So what can we do? Well, there's a fairly simple thing that we can do that's based on a basic idea of fractions, that it is always legal to multiply the numerator and the denominator of the fraction by the same thing. And what I'm going to choose is just exactly a duplicate of the denominator. And I'll show you why in a minute. So I'm multiplying the numerator and the denominator by the principal square root of 5. Now, why is that helpful? In the denominator, where we see more than one radical, we remember the product rule for radicals that says that if you have one radical times another, you can write a single radical over the product. So the principal square root of 5 times the principal square root of 5 is the principal square root of 5 times 5. In the numerator, you have one factor that's not under a radical and another factor that is under the radical. There's no way to combine those in any way. We simply write them as the quantity not under the radical times the radical, and we leave it alone. But now, focusing our attention back on the denominator, the principal square root of 5 times 5 is the principal square root of 25. And because 25 is a perfect square, we can rewrite that as simply a 5. And if you notice what happens, we no longer have a radical in the denominator, so we have succeeded in rationalizing the denominator. Now, if the fraction can be simplified, we should do that. For example, you will see very plainly that the 5 in the denominator divides into the 25 in the numerator 5 times. And so my original expression can be simplified to 5 times the principal square root of 5. There's actually no denominator left at all. That's a simple example of rationalizing the denominator. Let's look at another example. Okay, here we have both a radical in the numerator and the denominator. The radical in the numerator is considered polite. That's okay. The rules of etiquette allow that, but the radical in the denominator does not. That's not okay. So I need to do something about the principal square root of 3 in the denominator. Before I get too far, though, it's a good idea to look at the radicals that are there and see if any of them simplify before we do anything else. So, for example, if you look in the numerator, the principal square root of 32 is a radical that can simplify. Let's do that first. Notice that 32 is the same as 16 times 2 and again using the product rule to split up the radical, that's the principal square root of 16 times the principal square root of 2 divided by 5 times the principal square root of 3. And the principal square root of 16 is 4, so already my expression is beginning to look simpler. But what's not polite is having that principal square root of 3 in the denominator. So, same trick as before. 4 times the principal square root of 2, 5 times the principal square root of 3. Multiply the numerator and denominator by a repeat of the radical in the denominator. And the purpose of that is that we would get in the denominator, we'll start in the denominator and we'll talk about the numerator in a minute, the principal square root of 3 times 3, which is 9. Now we can also apply the product rule in the numerator as well. The principal square root of 2 times the principal square root of 3 can be combined into one radical and be written as the principal square root of 6. Now the radical in the numerator again is not considered a problem, and looking in the denominator, the principal square root of 9 is 3. So I can get rid of the radical altogether, which is the horrible, terrible thing that we wanted to get rid of. And then finally we could say 4 times the principal square root of 6 over 15. And that would be our simplified answer with no radical in the denominator. Let's do one more example that's ever so slightly different. In this case, there is a radical over a fraction, and that is also considered impolite, in fact, scandalous. Scandalous, I say. So we cannot leave this answer the way it is. One of the other rules of radicals that we have seen is that a radical over a fraction can be split up by the quotient rule, looking at just the radical in the numerator and just the radical in the denominator. So I can rewrite this as negative principal square root of 8 over principal square root of 27 by the quotient rule again, splitting that up into a radical on both the numerator and denominator. Now, before you get too excited and multiply numerator and denominator by the square root of 27, it's always good to look at your radicals first and see if any of them simplify, and in this case, they really, really do. Notice that in the first of all, this negative sign just sits there. The principal square root of 8, the 8 factors as 4 times 2, and in the denominator, 27 factors as 9 times 3. So using my product rule, I can split the numerator into two radicals, split the denominator into two radicals, and those radicals that are over perfect squares can then be simplified. So I would have negative 2 times the principal square root of 2 over 3 times the principal square root of 3, having factored all of the radicands. Now, I still have my problem. I still have a radical in the denominator, but notice that the radicand is much simpler. So we'll utilize our trick again. Multiply numerator and denominator by the exact same thing. Just a repeat of the radical in the denominator. You don't have to worry about the 3, that's a whole number. Applying the product rule to sort of put these together, in the numerator we'd have square root of 2, principal square root of 2 times principal square root of 3 is the principal square root of 6. And then in the denominator, we'd have 3 times the principal square root of 3 times 3 is 9. This is exactly what we want to happen. The principal square root of 9 is a rational number. So we have negative 2, principal square root of 6, over 3 times 3. And 3 times 3, of course, is 9. So negative 2, principal square root of 6, over 9. And this answer is considered vastly more polite and appropriate for mixed company. So this is the way we will leave our answer. By the way, you will notice that there are a number of steps in here that you might realize, I think I could skip over a few of those. I see what's going on. Feel free to do that. And also you might notice that in my final answer, I really kind of have a choice. I've written in my answer here the negative in the numerator. I could also have simply left the negative out front. Both of those answers are considered equally polite. Rules of etiquette can be kind of arbitrary, but both of those are considered fine. So that is your etiquette lesson for today on rationalizing denominators.